Welcome back, learners. In the previous session, so we have discussed about assigning the loads on the frames, shells, everything. So now once your entire project is ready as per the requirement, so then the next is we are supposed to analyze and get the analysis results, and we have to go for the further design. Right now, before we go to the analyze, there is a first option, what you call it as check model. Now what is this check model indicates is, so when before you analyze, if you give your structure to be checked, then the ETABS will start checking each and every joints of your project, each and every frames, whether it may be beam or whether it may be column, then each and every shell, okay, each and every spring, if you have anything, whatever the things are included in your project, everything will be checked once. So once the checking is done, then if there is any issues, the warning will be given. Like for example, you have defined one column, the column dimension, and as well as the corresponding its the material, everything you have defined. Okay, but what happened is you have not assigned that particular column, whatever you have defined, to one particular column. You have just drawn it, but you have not assigned it. So then that warning will be shown. Or if there is any overlapping of the joints, or if there is any overlapping of the members, so that will also be shown properly. Okay, that will also be shown. If there is any overlapping of the joints or frames, that will also be shown properly. Okay, so then the next one is, if you have any loads which is not assigned properly, so even that can be checked. Okay, so after checking, so it will give you the error, so that if there is any mistakes, okay, if there is any mistakes, so easily what you can do, so you can easily able to rectify and you can go for the analysis, so that there will not be any error in getting the results. Okay, this is what it. So therefore, when I click on check model, you can see the first is the tolerance limit. Okay, the more and more you give the tolerance limit, so definitely your accuracy will be reduced. Okay, so if you give the less tolerance, then definitely the accuracy is going to increase. Okay, the accuracy is going to increase. This is what about the tolerance. So now when it comes to the joint, you can check that wherever two joints are there, so you can check only at those points, is there any issues there. If not, you can go to the joints and frames, wherever there is two frames is going to connect, whether it may be beam and column, so that joints also you can check. As well as you can check with the shells, wherever the shells is going to rest on the frames, that is on the beams or on the columns, those joints can be checked. Similarly, you can go to the frames, and in the frames I already told there may be a chances of overlapping, so that overlapping of the frames, it will be checked. Okay, so then the frames interactions with the tolerance limit, it will check, as well as the frame interaction with area, that means is there any issues with the frame and shells joints, that can be checked. Then even the shell checks means if there is any overlapping of the shells, that means sometimes while drawing you will be drawing the one slab, and above that you will be drawing another slab, such kind of issues will be there. So those things can be those things can be considered. Then check meshing for all the stories, so meshing also it can be done. Okay, then loading, whether the loading is applied for all the stories or not, so that can be checked. Then checking for the duplicate self mass, so there may be sometimes the chances of the duplication, so the duplication checking also it has to be done. Okay, so those everything has been done here. So then after that, even trim or extend frames, sometimes we already discussed in drawing, sometimes we used to extend some frames, and sometimes we used to trim the frames, right? So those options also, if we have done and we have not done properly, so those things can be checked properly. So that is all about the checking the model, right? So let us select everything and then we give OK. Okay, so then it will start checking. You can see that once the model is checked, if there is any error, the error will come here. Otherwise it will show the model has been checked, so no warning messages were generated. It means there is no any overlappings of beams, frame, shells, everything is proper. We can go for analysis. That is first option. Second option, you can see the set active degrees of freedom. What is this? You may have the doubt, right? This setting the active degrees of freedom is nothing but what it is you can see that whenever you have the 3D, right, you can see when I choose the 3D, your transition along X direction, transition along Y direction, transition along Z direction. Similarly, the rotation along X direction, the rotation along Y direction, the rotation along Z direction. All these things will be analyzed. Okay, that means all these things, all these 3 rotations and 3 translations will be analyzed. If I go to that XY XZ plane, you can see automatically XZ plane means you will be having 2 rotations and only 1 translation. That is along X direction is the translation, and Y and Z is the and only Y and Z is okay. XYZ plane means along X you have the transitional, and along Z you have the transitional, and only rotation along Y. Only those directions, only the joints will be analyzed. Okay, only in those directions the joints will be analyzed. Okay, so that is the one, that is X and Z plane. If you go to Y and Z plane, you can see the transition along Y and transition along Z, and no transition along X direction, but the rotation is only along X direction. Okay, then no Z rotation means you can see that UX, UY, UZ is considered, as well as RX and RY is considered. RZ will not be considered. So like that, whichever directions to be only analyzed, that option also you have an option. Since we are doing 3D, all the degrees of freedom, 6 degrees of freedom has to be analyzed. That is what we are going to set the degrees of freedom. Then after that, the next one more important thing is set load cases to run. Now, you know, we have defined here only 2 loads. One is dead load and another one is live load. Okay, one is dead load, another one is live load, right? Okay, one is dead load, another one is live load, right? Okay, so now you have an option that whenever you are analyzing a model, okay, whenever you are analyzing a model, so you have an option that whether you want to run both the loads, that is dead and live, or you want to run only one. Okay, whether you want to run both dead and live, or you want to run only one, right? You can see here that both dead is also running, live is also running, model is also running. You have an option to choose that. If you click on do not run this case, you can see only the dead and live will be analyzed, it will be run and it will be considered. Okay, otherwise no. So this model will not be run. Even you can choose this also do not run. Okay, so then these 2 will be run and you will get the results of only model and live. You won't get any results of dead. So if you make live as do not run, then only the model and dead will be run. So your live will not run and you won't get any results of live. So like this, any option you can choose. Okay, yes. So this is all the option. Then you can see that the diaphragm center of rigidity we are supposed to calculate. Okay, either you can calculate manually, I will be explaining how to calculate manually, or else you can choose this so that software itself automatically it will calculate the center of diaphragm. Okay, that is do not run or do not run option. If you click on run or do not run all, means automatically all will not be considered to run, or all will be considered to run. Okay, so this delete all results means whatever the results you get, it will be deleted. Okay, so then whatever the tables you get once the analysis is done, if you want to save it automatically, just click on this. Then once you click on this, it will ask you in which path that your file folder has to save. So like that it will be saved. But usually we don't choose this because lot of tables will come. Whichever tables is required, only that tables you can make it, you can select and you can save it. Okay, so that is load cases to run. Then this option we cannot use. So the next one is automatic mesh setting for floors, right? Yes, if you see the results, you can see that the software will be doing the meshing of the slabs and then it will analyze. Okay, so what you can do is, so you have an option that either you can analyze the entire slab as a single slab without doing meshing, or you can divide it into the so many number of parts and you can analyze it. That is what you call it as meshing. But to be frank, if you analyze in that way, that is doing by meshing, the more and more accurate results will be obtained. Okay, the more and more accurate results will be obtained. So therefore, so let us do in such a way that the meshing will be done. Okay, yes. So then even you have an option to change this values, whether you want each mesh of 4 square feet by 4 feet by 4 feet, or you want to reduce it less. If you make 2 by 2, then more meshings will be done. Okay, but analysis result will take more time. Okay, therefore let us have an optimum size. Let us do that. Even you can do it to 5 feet by 5 feet, 1 feet by 1 feet, or 2 feet by 4 feet, anything is okay. Okay, so that is about, that is automatic mesh setting for floors. Even the automatic rectangular mesh setting for the walls is also possible. Okay, floors in the sense it will do for the slab, and next is walls. Even for the walls can be done. Okay, then analysis model for non-linear hinges. I already told, whenever we are doing the soil structure interaction, we come across with the hinges. So therefore that hinges also analysis is required. Especially when we do that, we have to give the option here whether the hinges has to be done, it has not to be done, so whatever it may be. So those things we can choose and we can do it. Okay, so that is about the analysis. So the last one, once everything is set, then what you can do, you can go for run analysis. So once you go for the run analysis, okay, once you go for the run analysis, you can see that it will be analyzed, and like this the deformed structure will be shown. Okay, and here you have an option to choose the start animation. Okay, when you give start animation, you can see like this. Okay, when you give start animation, you can see like this how each and every member, how each and every beam, okay, or how each and every shell is going to behave. So like that animation will be shown. Even you can increase its speed or you can decrease its speed like this. Okay, you can see that maximum speed is obtained. Come to this, you can see that very low speed is obtained. So better have an optimum speed. Okay, so this is how about analysis. So then you can stop. Yes, so this is about the analysis one. Okay, so we will continue that how to get the analysis in the next lecture. Thank you, learners.